So we will start with the definition of a sequence. So whenever we say sequence, we mean a pattern or something like that. And what happens in a sequence? Ordering is very important. So what does it mean? It means that if I have a sequence 1, 2, 3, 4, 5, it means 1 is sitting at the first place, 2 is sitting as the second place, 3 at the third place, 4 at the fourth place, 5 at the fifth place. I cannot change the positions, okay? The sequence 1, 2, 3, 4, 5 is completely different from 1, 3, 2, 4, 5. So the most important thing about a sequence is that ordering is very, very important. So what is a sequence? Sequence is a particular pattern where ordering is very, very important. Now, when the ordering is very, very important, I would like to call in a term of a sequence in a particular way, okay? A sequence. So for example, the first term is written as A1. Please understand the terminology now. When I say A2, I will write the second term. When I write A3, it means third term. So in this case, 1 is A1, 2 is A2, 3 is A3, 4 is A4, 5 is A5. So we call AN as the nth term of a sequence. Okay, the person or the number or the element sitting at the nth place is called AN, the nth term of a sequence. So many a times the most important task is to identify how the nth term looks like. Okay, so for example, I give you a sequence like this. Okay, suppose I have a sequence like this: 1, 2, 3. So I put this inside curly brackets, 5, and so on. Now when I say so on, there are dots. That means my sequence is an infinite sequence. Infinite sequence means I will not stop the sequence. The sequence will go on. Okay, it will not stop at any point. And we are mostly interested in infinite sequences because it is very easy to identify a pattern or judge a finite sequence. The only problem occurs when we have an infinite sequence. So now this is an infinite sequence. So what is your A1? 1. What is your A2? 2. What is your A3? 3. What is your A4? 4. What is your A5? 5. Now, if somebody asks you what is A1000, you can clearly see that A1 is 1, A2 is 2, A3 is 3, A4 is 4, A5 is 5. So A1000 is going to be 1000. So if I want to generalize the pattern, AN is going to be N. So this is how we identify nth term of a sequence. Okay, so what is a sequence? A sequence is a collection where ordering is very important. The place at which the term is sitting cannot be changed. It cannot be interchanged with any other element. Okay, so and the first task that comes to our hand is identifying the nth term and writing a general formula for it. Okay, now for example, we have another sequence which is of this type. So you have a sequence 1, 3, 5, 7, 9, and so on. So you want to write the nth term of this sequence. So you can notice that this is the first odd number, this is the second odd number, this is the third odd number, and so on. So you can write AN as 2n minus 1, where n belongs to the set of natural numbers. So when you take n equals to 1, you get 2 into 1 minus 1, which is 1. When you put n equals to 2, you get 2 into 2 minus 1, which is 3. When you put n equals to 3, you get 2 into 3 minus 1, which is 5, and so on. So this is the pattern for this particular sequence. So you have to identify the nth term of a sequence. Okay, so this is what is all about the nth term of a sequence. Now I'll share the sheet with you, and we will do some questions related to the pattern in a sequence. Okay, so yeah, for example, we have this sequence practice questions, and I want to write the pattern, find an expression for AN and determine whether the sequence converges. So we will talk about the convergence later on. First, I want to identify the pattern. Okay, so if you look at A1 in this, A1 is 1. So I can write it as 1 upon 1. Okay, so A2 is 4 upon 3. A3 is 9 upon 7. A4 is 16 upon 15, and so on. So you can notice one thing, that the numerators are squares. Okay, So if you look at A1, it is 1 square divided by something. We will talk about that something. A2 is 2 square divided by something. A3 is 3 square divided by something. A4 is 4 square divided by something. Okay. So the numerator, the pattern, okay, Pragya, I have written A1 equals to 1 upon 1 because first of all, A1 is 1 over here. Okay. I'm writing it as 1 upon 1 because I want to reach a particular pattern. Okay. So can you identify what should be the pattern of the denominators? Can you identify? This is, I can write it as 2 power 1 minus 1. I can write it as 2 power 2 minus 1. I can write this as 2 power 3 minus 1. I can write 15 as 2 power 4 minus 1. And similarly, I can write A5 as 5 square divided by 2 power 5 minus 1. So now try to find out a general term. A general term will look like n power 2 divided by 2 power n minus 1. Is it clear to everybody like how we arrived at the general term? You have to observe. Okay, it will not come very easy, but with practice and with observation, it will come. The first task was to identify the nth term of the sequence. Now we will understand a concept of convergence or divergence of a sequence. Okay. So what do you mean by it? First of all, let us try to understand what is convergent and what is divergent. Convergence means going towards something fixed. Okay. For example, if you take the sequence 1, 2, 3, 4, 5, 6, and so on, you know that as n is increasing, an is increasing, it is not going to stop. That means as n becomes very large, an becomes large too. What does it mean? It means limit as n tends to infinity, an is infinity. Okay. That means not fixed. And whenever we have limit, so whenever limit n tending to infinity an is plus infinity or minus infinity, we call that the sequence is a divergent sequence. Okay, that means my sequence is not approaching a finite number as n is becoming large and large. So that is how we put it, emotionally in words. But if you talk about mathematics, suppose mathematically you have to find out whether a sequence is convergent or not. So you calculate the limit of an as n tends to infinity. If the limit is either infinity or minus infinity, the sequence is divergent. Okay. Now we are interested in convergent sequences. So a sequence, so this is how we write curly brackets an. Okay. A sequence an is said to be convergent. Okay. If and only if limit n tending to infinity an is L, where L is finite. Okay. It's a finite number. Infinity is not a real number. Minus infinity is not a real number. Okay. They are extensions of real line. They cannot be attained. So whenever a sequence, whenever limit as n tending to infinity is L and L is a finite number, we say that the sequence is convergent and sequence an is converging to L. Okay. So for example, if you take this sequence, an equals to 1 upon n. So if you write the first term, it is 1, the second term half, the third term 1 by 3, the fourth term 1 by 4, the fifth term 1 by 5, and so on. So as n is increasing, the denominator is increasing. If the denominator is increasing and the numerator is fixed, the number is becoming very, very less. Because 1, that this is half is 0.5, 1 by 3 is 0.3333. 1 by 4 is 0.25, 1 by 5 is 0.2. So the number is becoming very, very less. For example, when I talk about 800, it will be 1 upon 100, which is 0.01. Then I'll say 8,000, it is going to be 1 upon 1,000, which is going to be 0.001. So as n is increasing, okay, as n is increasing, an is becoming smaller and smaller. And you can see that as n goes to infinity, 1 upon n goes to 0. If n becomes 1 crore, 1 crore, so an will become 1 upon 1 crore. So it is getting closer and closer to 0. It will never be negative. These terms will never be negative because 1 divided by a natural number will be positive. So they are reaching towards 0. 0 के नीचे नहीं जाएंगे. So this sequence is said to be convergent to 0. Okay, so that is the definition of a convergent sequence. So we have learned convergent sequence where the limit is finite. We have learned divergent sequence where the limit is either plus infinity or minus infinity. Now the third type of sequences are those sequences where neither the limit is plus infinity or minus infinity nor the limit is finite. Such types of sequences are known as oscillating sequences. So let us see. ऑसिलेट का क्या मतलब होता है? एक जगह से दूसरी जगह भागना, इधर 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 इधर, मतलब my place is not fixed. I'm jumping from one place to another, and the places where I'm jumping are fixed. For example, let us take this sequence. Now, suppose I take this sequence 0 1 0 1 0 1 0 1 and so on. Now, limit n tending to infinity an does not exist. इसका क्या मतलब है? ना तो ये इंफिनिटी पे जा रहा है, ना ये माइनस इंफिनिटी पे जा रहा है, ना ये जीरो पे जा रहा है, ना ये वन पे जा रहा है. क्यों? क्यों? बिकॉज देर आर इनफाइनाइट नंबर ऑफ जीरोस एंड देर आर इनफाइनाइट नंबर ऑफ वंस इन दिस सीक्वेंस. सो अगर आप इसके दो सब सीक्वेंस बनाओ, एक सब सीक्वेंस बनाओ जिसमें सारे जीरो, जीरो जीरो जीरो, और दूसरा सब सीक्वेंस बनाओ सी एन जिसमें सारे वन हो, तो आप नोटिस करोगे कि बी एन जा रहा है जीरो की तरफ एंड सी एन इज कन्वर्जिंग टू वन. नाउ that is the beauty of a convergent sequence. If a sequence is convergent, then if you take an infinite subsequence of that sequence, that should also be convergent to the same number. Now you can see that there are two subsequences which are going to different numbers. This sequence can never converge. So whenever you see a sequence where the numbers are, repeating infinitely many times, more than one number is repeating infinitely many times, that is an oscillating sequence. One very common example of an oscillating sequence is the sequence which takes the form an, which is this. So this is going to be when I take n equals to 1, so minus 1. When I take n equals to 2, 1. When I take n equals to 3, minus 1, then 1, minus 1, then 1. So this sequence is never going to converge. This sequence is oscillating between 1 and minus 1. Okay. So such type of sequences are known as oscillating sequences. All right. The sequences where the limit does not exist. That means as n goes to infinity, there is no fixed limit. It is neither plus minus infinity, nor it is a fixed number. Those kind of sequences are known as oscillating sequences. They are called oscillating because, they're jumping from one number to another. For example, 0, 1, 0, 1, 0, 1. You can also take this example, an equals to 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, and so on. इसमें तो और ज्यादा खतरनाक हो चुका है. तीन नंबर्स के बीच में 0 1 2 0 1 2 0 1 2. So I'll never be able to reach a particular number as n goes to infinity. For each of the following sequences, determine whether it converges. If so, find its limit. Very easy. A sequence is convergent if limit n tending to infinity an is fixed. It's a number. So a में करते हैं limit n tending to infinity 2n plus 1 upon 5n minus 2. So whenever the degree of the numerator and the degree of the denominator is same, आप देखिए यहाँ पर n की पावर 1 है और यहाँ पर भी n की पावर 1 है. So the limit is the quotient of these terms. Okay. और अगर आपको ये शॉर्टकट नहीं समझ में आता है तो आप क्या करिए, डिवाइड द न्यूमरेटर एंड डिनोमिनेटर बाय n. So 2n upon n plus 1 upon n divided by 5n upon n minus 2 upon n. So this is limit n tending to infinity 2 plus 1 upon n, 5 minus 2 upon n. Now put as n goes to infinity. This is going to be 2 by 5 because as n goes to infinity, this goes to 0, this goes to 0. I hope everybody knows that when I have a constant divided by n, and as n becomes very large, as n becomes infinite, that thing goes to 0. So the limit is 2 by 5, or you can learn it like this. If the degree of the numerator and denominator is same, the limit is going to be 2 by 5. Okay. Now look at question number 2. 1b. An is this. So an is minus 1 power n, n minus 1 upon 2n. Now this is very, very interesting. So an is this. So when I write limit n tending to infinity an, this is a limit n tending to infinity minus 1 power n, n minus 1 upon 2n. So now I can write these as a product. So this should be equal to limit n tending to infinity minus 1 power n into limit n tending to infinity n minus 1 upon 2n. So this should be limit n tending to infinity minus 1 power n. Let us calculate this limit. So divide the numerator and denominator by n. So 1 minus 1 upon n, 2n upon n. Okay, so this will be limit n tending to infinity minus 1 power n, and now this is 1 upon 2. Okay, so this is half. Now this particular limit exists if and only if this limit exists, and we have already seen that this limit does not exist. Why? Because minus 1 power n will be this sequence, minus 1 1 minus 1 1 minus 1 1 and so on. This is an oscillatory sequence, so this limit is not existing. So this is a non-convergent sequence. In this question, they have just asked you whether it converges. So you will write no. They have not asked you anything, whether it is going to oscillate. And if they ask you that, it is oscillating, it is not diverging. It will oscillate between plus half and minus half. Okay. So, but they have asked you determine whether the series is convergent. So this series is not convergent. Therefore, we cannot find the limit also. In the first question, part A, it was convergent and it was convergent to 2 by 5. Okay. If you have, limit n tending to infinity polynomial divided by polynomial. Okay. So for example, you have a situation like this, n square plus 2n plus 5 upon n square plus 3n plus 6, something like this. So you can see this is a polynomial whose degree is 2, and this is a polynomial whose degree is 2. So whenever the degree of the numerator and degree of the denominator are same, the limit is nothing but these coefficient 1 divided by 2. That's it. Okay, that is what I said. And if you don't want to remember that, just divide the numerator and denominator by the highest power of n, that is n square, and you will find it. Okay, we use the L'Hopital rule. So limit n tending to infinity, this is 2n minus 1 upon n. So as n goes to infinity, 2n becomes very, very large. Okay, 2 ki power 100, 2 ki power 1000. As n is increasing, 2 power n becomes very large, and I'm just subtracting 1 from it. So it is a very large number. That means infinity. And if n goes to infinity, infinity. So I have infinity by infinity form. So whenever I have infinity by infinity form, you will differentiate the numerator and denominator with respect to n. So when you differentiate n, it will be 1. When you differentiate 2 power n, it will be 2 power n log 2. Okay, and derivative of 1 is 0. I hope everybody knows this. D by dx of a power x is a power x log a. So I am differentiating d by dn of 2 power n, which should be 2 power n log 2. So now, as n goes to infinity, this whole thing goes to infinity. So it is divergent. Why this whole thing goes to infinity? Because the denominator is 1. Log 2 is a constant. Now 2 power n. Now as n goes to infinity, 2 power n becomes huge. So therefore, this limit goes to infinity. So this is a divergent sequence. So here you have to write non-convergent. Okay. So this is the definition of a bounded above sequence. This is the definition of a bounded below sequence. If a sequence is bounded above, okay. If a sequence is bounded below and above, okay, it's called a bounded sequence. अगर एक sequence ऊपर से भी bounded है, नीचे से भी bounded है, यानी कि पूरा का पूरा sequence इन दो boundaries के बीच में है. In that case, we say that the sequence is bounded. Okay, I'll give you example. For example, if you look at an equals to 1, 1 by 2, 1 by 3, 1 by 4, and so on, you notice one thing. You notice one thing, that your an is always going to be less than or equal to 1. an किसी भी condition में 1 से बड़ा नहीं होने वाला, because an is decreasing. Okay, and an is always greater than 0. ये 0 से ना तो ये 0 होगा, ये 0 infinity पे हो रहा है, where n is becoming very large. Okay, और ये negative भी नहीं होगा. So it is bounded below by 0 and it is bounded above by 1. So an is a bounded sequence. Okay, it is bounded below by 0 and bounded below by above by 1. So bounded below by 0 means it will not go below 0. Bounded above by 1, it will not go above 1. It may or may not attain its bound. So ये जो मैंने आपको definition लिखवाई है, इसमें इसके बदले less than sign भी हो सकता है, ठीक है, और equality भी हो सकता है. So that is the definition of a bounded sequence. Then we have increasing sequence, decreasing sequence. Increasing sequence का क्या मतलब होता है? ये real life में ले लीजिए आप कि as n is increasing, an is increasing. ये मतलब होता है increasing sequence का. So that is what they have told you. A sequence is increasing if an plus 1 is greater than an for every n, and decreasing if an plus 1 is less than an for all n. It is called monotonic if it is either increasing or decreasing. So what is a monotonic sequence? A monotonic sequence is a sequence which is either increasing or decreasing. Just look at this an. आप देखिए, as n is increasing, an is decreasing. Okay, आप देख लीजिए, an is 1 upon n. So what is an plus 1? It is 1 upon n plus 1. So अगर आपको mathematically prove करना है, आप क्या लिखोगे? n is less than n plus 1. So when you take the reciprocal, the inequality will reverse. So an is greater than an plus 1. So this is a decreasing sequence because I can write an plus 1 less than an. So this is a decreasing sequence. So I will say that it is a monotonically decreasing sequence. But it should not happen that कहीं पर decrease हो रहा है, कहीं पर increase हो रहा है. For example, if you have a sequence 1, 0, 3, 2, 5, this is neither increasing nor decreasing. ये 1 था, 1 से कम हो गया, अब ज्यादा हो गया, फिर कम हो गया, फिर ज्यादा हो गया. So I cannot term it as an increasing or a decreasing sequence. So a monotonic sequence is the one which is either only increasing or only decreasing. Okay, I will not have both the cases together. So that is the definition of a monotonically increasing, monotonically decreasing sequence, and we should know what are bounded sequences. So now we start with the concept of series. Okay. Now, please, you never get confused between a series and a sequence. Okay. So what is a, first of all, हमने पढ़ा कि sequence क्या होता है. So what was a sequence? A sequence was like A1, A2, A3, A4, A5, and so on. Okay. Now what is a series? If I write the terms of this sequence and take the sum, or you can use this, n going from 1 to infinity. That means if I write this as A1 plus A2 plus A3 and so on, and I can write this as this. So this infinite sum of the terms of this sequence is called an infinite series. Okay. So you have a sequence. What did you do? You are adding all the terms of that sequence till infinity. Okay. So that infinite sum which you obtain is called an infinite series. Okay. For example, अभी हमने किया है, you took this sequence an equals to 1 upon n. So that means 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. So when you write summation n going from 1 to infinity an, this is summation n going from 1 to infinity 1 by n, which is 1, 1 by 2 plus 1 by 3, and so on. This is called an infinite series. So never get confused between a series and a sequence. Okay. One more example. For example, in the last class we studied progressions. Okay. So we did these geometric progressions. Geometric sequence बोल सकते हैं. And progressions are particular kind of sequences only, geometric sequences and progressions. Muskan, I am giving you this example. Now please look at this example very carefully. So geometric sequence कैसा होता है? AR square, AR cube, and so on. इसकी nth term कैसी होती है? AR n minus 1. So this is a geometric sequence. But when I add them, summation n going from 1 to infinity AR n minus 1. इसका क्या मतलब है? A plus AR square. This is called infinite geometric series. When I write sequence, I write the terms separated with commas, first term, second term, third term, fourth term, and so on. When I write the series, I include a plus sign. It means I am adding all the terms of that sequence. That is the difference between a sequence and a series. Is it clear now? Yes, the sum of a sequence is a series. The sum of an infinite sequence is an infinite series. We are interested in infinite sequences and we are interested in infinite series because एक finite sequence आपके पास, आप उसके बारे में सब कुछ डिसाइड कर सकते हैं. Similarly with a finite series, finite number of terms का sum है, आप उसे कैलकुलेट कर सकते हैं. प्रॉब्लम कहाँ पर आती है? When we are talking about infinite number of terms. So we have already decided that n going from 1 to infinity an is called a series, an infinite series, and it is made by adding all terms of an infinite sequence S, infinite sequence AN. ठीक है, अब हम आज की क्लास में ये डिसाइड करेंगे that when do we say that an infinite series actually has a sum. मैं निकाल सकती हूँ sum को, या वो convergent है कि नहीं. Okay, so let S1 equals to A1, S2 equals to A1 plus A2, S3 equals to A1 plus A2 plus A3. Are you understanding what is happening? At every stage, I am adding one more term. So S1 is the sum of first term, S2 is the sum of first two terms, S3 is the sum of first three terms. आप ऐसे ही तो करोगे ना. अच्छा ठीक है, this is the sequence. Let me see what the first term looks like. Then let me add the first two terms. Then let me add the first three terms. Let me see what is happening. So that is what we are trying to see. But we cannot do this continuously for, S100, S200. So we have to come up with a pattern. So similarly, Sn will be A1 plus A2 plus A3 till An. So आप क्या करेंगे, आप Sn को लेंगे. Okay. So you will consider the sequence Sn. क्या मतलब है, मैंने एक सीक्वेंस बनाया S1, S2, S3 and so on. Now, if limit n tending to infinity Sn is equal to S, finite, we say that sigma n going from 1 to infinity En is S. इसका क्या मतलब है? If you want to decide whether a series is convergent or not, you take the sequence of partial sums. इसको बोलते हैं sequence of partial sums of the series. Partial sum इसलिए बोलते हैं because हम sum को रोक रहे हैं. First term, फिर first two terms, फिर first three terms, फिर first four terms. So this series will converge if and only if this sequence Sn will converge. Okay. If this sequence will converge to a particular number S, then only this infinite series has a sum S. So we have defined convergence of this series in terms of convergence of a sequence. और हम convergence of a sequence already पढ़ चुके हैं. Okay. So if I want to decide whether a series is convergent or not, what do I decide? I look at the sequence of its partial sums. If that sequence of partial sum is converging, then the series will converge. Otherwise, the series will not converge. Now, this might sound very complicated. I will give you a very nice example and see what I'm doing. For example, you have this series An equals to n. Okay? So this series is 1, 2. This sequence is 1, 2, 3, 4, 5, and so on. So you want to discuss the convergence of sigma n going from 1 to infinity an, which is sigma n going from 1 to infinity n. आप notice करेंगे कि an n है. A1 is 1, A2 is 2, A3 is 3. So here an is n. Okay. इसीलिए मैंने ऐसा लिखा. So what did I tell you? What you have to do? You have to look at the sequence of partial sums. Okay. So you look at Sn. Sn is A1 plus A2 till An. So this is 1 plus 2 plus till n. Now this is the sum of first n natural numbers. I hope everybody knows what is the sum of first n natural numbers. If not, it is n into n plus 1 by 2. Okay. So मुझे Sn की एक particular form मिल चुकी है. Okay. Now I will see what is limit n tending to Sn looks like. So this is limit n tending to infinity n square plus n upon 2. So as n goes to infinity, ये देखिए 2 आपका finite है. Infinity square plus infinity, it's going to be infinity. So this is not a fixed number. Therefore, sigma n going from 1 to infinity an is not convergent. In fact, it is divergent. Okay. So this series is divergent because this sequence of partial sum is divergent. So if the sequence of partial sum is convergent, the series is convergent. If the sequence of partial sums is divergent, the series is divergent. Have I made myself clear?